Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So this is a problem from 1970 IMO Longlists, problem 21. In the triangle ABC, let B' and C' be the midpoints of the sides AC and AB respectively, and H the foot of the altitude passing through the vertex A. So let's draw the figure first. We have our triangle ABC here, and the foot that passing through vertex A is H. And we also know that B' is a midpoint of AC, and C' is a midpoint of AB. So we want to prove that the circumcircle of the triangle AB', C' and the triangle B', CH, and the triangle B, C'H. So we want to prove that these three triangles, the circumcircle of these three triangles have a common point I, and that line, the line HI passes through the midpoint of the segment B', C'. So basically, we can assume this is a point I. Right? We want to prove that the circumcircle of these three triangles passing through a common point I and HI meets B', C' on the midpoint of B', C'. So for the first question, that these three triangles have a common, the circumcircle of these three triangles have a common point. That's very, I think we proved that before, right? That's very straightforward to prove. Let's just consider that we have the intersection point of the circumcircle of triangle A, C', B', and B, C', H, right? So that means we know that A, C', I, B' are cyclic. Right? We find this point I from the circumcircle of triangle A', C', B', and the triangle B, C', H. Right? And we also know that B, H, I, C' are cyclic. Right? That means the angle B', I, C' plus angle BAC equals to 180 degree, and the angle, so this angle, right, B', I, C' plus angle BAC equals to 180 degree. And because these 4 points are cyclic, so angle C' IH plus angle B equals to 180 degree, right? C' IH is this one, plus this equals to 180 degree. So, and we also know that angle BAC plus angle B plus angle C equals to 180 degree, and angle B' I, C' plus angle C' IH plus angle B' IH equals to 360. Right? Based on this, just look at here, this one. So we can add them together, right? That means the angle the angle B' IH equals to 360 minus angle B' I, C' minus angle C' IH, right? which equals to 360 minus angle B prime IC prime, B prime IC prime, that is 180 degree minus angle A, right? And minus angle C prime IH, that is 180 degree minus angle B, which we can get that it equals to angle A plus angle B, which means angle B prime IH plus angle C equals to 180 degree, which means B prime IHC are cyclic, right? So we get B prime IHC are cyclic. Now the question is that if we extend HI meets B prime C prime on a point, on this point, let's call it M. We want to prove that M is a midpoint of B prime C prime, right? Think about what is IH? What is IH? I and H are the common points, or IH is a common chord of the circle BHIC prime and circle CHIB prime, which means IH is a radical axis of circle BHIC prime and circle CHIB prime, right? That means because M is on the IH, is on the radical axis, means the power from M to the circle BHIC prime and the power of M to the circle CHIB prime are same. And now the question is that, just think about this, if M is a midpoint, that means MC prime, if M is a midpoint, that means MC prime equals to MB prime, right? And also we know that M is on the radical axis, that forces C prime, B prime to be the tangent line of these two circles, which means we just need to prove that MC prime is a tangent line of the circle HIC prime B, and MB prime is a tangent line of circle IHCB prime. Then we solve the problem. Okay, so let's think about how to prove that MC prime is a tangent line of the circle HIC prime B, right? So for here, we know that because C prime and B prime are the midpoint of AB and AC respectively, and AH is perpendicular to C prime, B prime. So we know that the triangle AC prime, B prime is congruent to triangle HC prime, B prime, which means the angle AC prime B equals to angle HC prime, B prime. Sorry, the angle AC prime, B prime, right? This angle equals to this angle. And because C prime, B prime is in parallel with BC, so this angle, or let's say this angle, the angle B prime, C prime, H, this one equals to this one. Right? It actually tells us C prime H equals to C prime B. Right? That's very straightforward, just because triangle AHB is a right triangle and C prime is a midpoint. So we know that this angle equals to this angle equals to this one equals to angle B. Okay, so in the quadrilateral BHIC prime. If we connect BI, we know that the angle C prime HB equals to angle C prime IB, right? Because this is a cyclic quadrilateral. So we already know that this angle equals to this angle. And the target, remember the target is to prove that MC prime is a tangent line, which means that we want to prove if this is a tangent line, we want to prove that this angle, the angle MC prime I, equals to angle C prime HI, or the angle C prime BI, right? So now we connect AI here. And we know that because AC prime, IB prime are cyclic, that means the angle IC prime B prime equals to angle IAB prime. So we know this IAB prime, this angle, right? This angle equals to this one. And remember that we want to prove this one equals to this one equals to this one equals to this one. So now you can see we have this angle here, and we want to prove that this angle is this angle, right? That's what we want to prove. And if you look at this triangle and this triangle, right? Because the angle AIB prime equals to angle AC prime B prime. So we have this. That means we just need to prove triangle AIB prime is similar to triangle BIC prime. Okay, so just collect out the information. We just proved that this angle equals to this one, equals to this one, equals to this one, equals to this one. And also this angle equals to this one. So all of them are equal, and we know that this angle equals to this angle, right? And let's think about the angle, this one here. Okay, the angle AC prime I. Because BHIC prime are cyclic, that means angle AC prime I equals to angle BHI equals to this one, BHI. And because IHC B prime are cyclic, that means this angle equals to this one, right? So based on this angle equals to this angle, we know that the angle AB prime I, the angle AB prime I equals to angle BC prime I, right, equals to this one. Now we can see in the triangle AIB prime and the triangle IBC prime, we know these two angles are equal, and these angles are equal, which means that angle IAB prime equals to angle IBC prime. Right, the angle IAB prime equals to angle IBC prime. And because angle IBC prime equals to angle IHC prime, so we know that angle IC prime B prime equals to angle C prime HI, which means MC prime is a tangent line of the circle IHBC prime. We can do the similar thing for this part. Then we just proved that MC prime is a tangent for the MC prime is a tangent for the circle IHBC prime, and MB prime is a tangent for this part. That means B prime C prime is a common tangent for the circle IHBC prime and circle IHCB prime. Right, and this is radical axis. So we know that MC prime, the power of M to this circle equals to MC prime squared, which equals to MI times MH, which equals to MB prime squared. So MC prime equals to MB prime. That means M is the midpoint of B prime C prime. Okay, so this problem is not really a difficult one. It's just a lot of angle chasing. Except that I don't think it's too difficult. Just need to notice the radical axis here. Okay, I hope you like this video. See you in next one. Thank you.